Rational expressions. Excluded values. Excluded values are any values that make rational expressions undefined. What you have to look for is anything that would make the denominator equal to 0, because 0 is not allowed in the denominator. If we look at 5 over 0, this is undefined because the denominator equals 0. Anything divided by 0 is undefined because the denominator equals 0. When you are asked for excluded values, or what would make an expression undefined, you are only concerned if there are variables in the denominators. For example, 2 plus x over 3 will never be undefined because the denominator doesn't have a variable. It has a constant. 3 will always be 3. It will never be a 0 like a variable could be. So it will never be undefined. Let's look at 7 over x and see when it will be undefined. So we are concerned when the denominator is equal to 0. So if x itself is 0, then this expression is undefined. So 0 itself is the excluded value. We might write it as x cannot be equal to 0, or x is an excluded value. Depends on how the question is worded, but both mean the same. Let's look at another example. Find the excluded values for 5 over x plus 3. So we want to know what value or values could be in the x spot to make this denominator 0. So something plus 3 equals 0. And it would be a negative 3. That's the only thing that would add to 3 to give us 0. So we'll say x cannot be negative 3. As you get more complicated expressions, you can just take that denominator and set it equal to 0 and then solve. So to isolate the x, subtract the 3 from both sides. So x equal to negative 3, but this is what would make the denominator 0. So this is just your calculation in finding it. So you want to say x cannot be negative 3 because that would make the denominator 0. Here's an example where we do have a more complicated denominator. We're still looking for excluded values, and so we want to know when is this denominator equal to 0. So when is 2x minus 1 equal to 0? So we'll just set it equal to 0 and solve. Add a 1 to both sides. So 2x equals 1 and divide by 2. So x equals a half. So if we put a half in, 2 times a half would give us 1, and 1 minus 1 would give us 0 in the denominator. So we want to say x cannot be 1/2. That is an excluded value. For this example, if our denominator was multiplied out, it would make a quadratic. So if we were looking to see when it equals 0, we would have a quadratic equation. Now we won't really multiply it, but we can see it would be x squared, but it's already factored. So x plus 4 times x plus 2, when is that equal to 0? You are set to use the zero product law. Either x plus 4 equals 0 or x plus 2 equals 0, and then solve. So subtract your 4. And here subtract a 2. So we have two excluded values. We cannot let x be negative 4 because it would make this parentheses 0 times negative 2 is going to be 0. 0 times anything is 0. And if we put the negative 2 in, it would make this parentheses 0 times the 2 would be 0. So our excluded values are negative 4 and negative 2. You would need to find the excluded values before you simplify the expression. This expression will simplify. You can divide out the x plus 4s, but find the excluded values first. So we have one last example. When we look at our denominator and set it equal to 0, we have a quadratic equation because the exponent equals 2. So we have to use the zero product law. We have a 0. We need to factor on the left-hand side, different signs, split the x's, and we can do 6 and 1 or 3 and 2. Combine to give a 1, so it's going to be 3 and 2. And we'll just double check. Minus 2x plus 3x gives plus 1x. Now use your zero product law. So x plus 3 equals 0, or x minus 2 equals 0. Then solve. X equals negative 3, and here add your 2. X equals 2. Remember what you were doing though. Don't get so bogged down in this that you forget. You were trying to find what to throw away, because these values would make the denominator 0 and make the problem undefined. So these are our excluded values. So x cannot be negative 3 and 2.